In our previous video, we have discussed two problems based on Cauchy's integral formula. Today we will discuss few more problems based on that concept. Third problem, evaluate integration of z divided by z square plus 1 into z square minus 9 with respect to z, where C is the circle of mod z is equal to 2. Solution, the contour C from mod z is equal to 2. It is a circle with mod z can be written as mod of z minus 0. Therefore, its center is at origin and radius is 2. Z square plus 1. This equation roots can be written as z is equal to plus or minus I. Since mod z is equal to 2, these roots lie inside the circle, and z square minus 9, the roots of this equation can be written as z is equal to plus or minus 3. These points lie outside the circle C from mod z is equal to 2. Here the given function is considered as the pi of z, that is z divided by z square plus 1 into z square minus 9. Since z is equal to plus or minus lie inside the circle, pi of z is not analytic at these points. Give it as equation number 1. Since pi of z is not analytic at z is equal to plus or minus I, pi of z can be written as z divided by z square minus 9 whole divided by z square plus 1. Because the function is analytic at z is equal to plus or minus 3, which is equal to z divided by z square minus 9 whole divided by z square plus 1 can be written as z minus I into z plus I, because its roots are z is equal to plus or minus I. The numerator function can be taken as f of z. Therefore, here f of z is equal to z divided by z square minus 9. Give it as equation number 2. Now we have to calculate the value of 1 divided by z minus I into z plus I by using partial fraction method. In our previous video, we have discussed how to calculate the value of 1 divided by z minus I into z plus I. Here, directly, I am going to take it as 1 divided by 2 times of I into z minus I minus 1 divided by 2 times of I into z plus I. Now, multiplying f of z for above equation and integrating it with respect to z, we get integration of f of z with respect to z divided by z minus I into z plus I over C is equal to 1 divided by 2 times of I is a constant, keep it outside of the integral. Therefore, integration of f of z divided by z minus I with respect to z over C minus 1 divided by 2 times of I integration of f of z divided by z plus I with respect to z over closed contour C. Now we have to use the Cauchy's integral formula, that is 2 pi I into f of I is equal to integration of f of z divided by z minus I with respect to z over the closed contour C. Give it as equation number 3. F of z is nothing but it is z divided by z square minus 9, and z minus I into z plus I can be written as z square plus 1, which is the given integral. Now we have to calculate the value of this integral by using Cauchy's integral formula, which is equal to 1 divided by 2I, it is a constant, keep it as it is. The value of this integral by using equation number 3 can be written as 2 pi I into f of a. Here a value is I, therefore which can be written as 2 pi I into f of I minus 1 divided by 2I as it is. The value of this integral is 2 pi I into z plus I can be written as z minus of minus I. Therefore, here a value is minus I. Therefore, it is f of minus I. Here 2 times of I will get cancelled. We get pi, and inside the bracket we have to put the value of f of I. That is f of z is z divided by z square minus I. Now we have to replace z by I in the equation number 2. That is I divided by I square minus 9 minus here also 2 times of I will get cancelled. We get simply pi inside the bracket Now we have to replace z by minus I in the equation number 2, that is minus I divided by minus I whole square minus 9, which is equal to pi. Inside the bracket I divided by I square value is minus 1 minus 9 minus of pi. Inside the bracket it is minus I whole divided by square of any negative term is a positive term, therefore minus I square is I square, again its value is minus 1 minus 9, which is equal to pi times of I divided by minus 10 minus of minus pi into I whole divided by minus 10, which is equal to minus pi into I divided by 10. Minus will get cancelled, we get minus pi into I divided by 10, which is equal to minus 2 times of pi into I divided by 10, which is equal to minus pi into I divided by 5. This is the value of given integral. Fourth problem, evaluate integration of sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 with respect to z over c, and they have given the circle of mod z is equal to 3. The contour C from mod z is equal to 3, it is a circle with center at origin and radius as 3. Consider the given function as pi of z, give it as equation number 1. Now we have to calculate the value of 1 divided by z minus 1 into z minus 2 by using partial fraction method. That is, its value is 1 divided by z minus 2 minus 1 divided by z minus 1. Here the numerator function is sin pi z square plus cos pi z square, therefore it is taken as f of z. Give it as equation number 2. Now on multiplying f of z for this equation on both the sides and integrating it with respect to z, we get integration of sin pi z square plus cos pi z square whole divided by z minus 1 into z minus 2 with respect to z over c is equal to integration of f of z divided by z minus 2 with respect to z over c minus integration of f of z divided by z minus 1 with respect to z over c. Now we have to apply the Cauchy's integral formula, that is 2 pi I into f of a is equal to integration of f of z divided by z minus a with respect to z over c. Give it as equation number 3. Left hand side is given integral which is equal to, the value of this integral is 2 pi I into, here a value is 2, therefore it is f of 2 minus the value of second integral is 2 pi I into, here a value is 1, therefore it is f of 1 equal to 2 pi I into, now we have to replace z by 2 in the equation number 2, that is sin 4 pi plus cos 4 pi minus 2 pi I. Now we have to replace z by 1 in the equation number 2, that is sin pi plus cos pi, which is equal to 2 pi I inside the bracket. Sin 4 pi value is 0 plus cos 4 pi value is 1 minus of 2 pi I inside the bracket. Sin pi value is 0, cos pi value is minus 1, which is equal to 2 pi I minus into minus plus 2 pi I, which is equal to 4 pi I. This is the value of given integral. Fifth problem, if C is a circle of mod z is equal to 3, then evaluate integration of e to the power 2z divided by z minus 1 into z minus 2 with respect to z over the closed contour C. Solution, the contour C from mod z is equal to 3, it is a circle with center at origin and radius as 3. Now consider the given function as pi of z, that is e to the power 2z divided by z minus 1 into z minus 2. The root of this equation is z is equal to 1 and the root of this equation is z is equal to 2. Therefore, the function pi of z is not analytic at these points, that is at the points z is equal to 1 and 2. Give it as equation number 1. Here the numerator function is e to the power of 2z, therefore it is taken as f of z. Give it as equation number 2. Now by using partial fraction method we have to calculate the value of 1 divided by z minus 1 into z minus 2, that is its value is 1 divided by z minus 2 minus 1 divided by z minus 1, or else simply taking the LCM of this equation, we will get back the previous equation. Now, on multiplying f of z for above equation on both the sides and integrating it with respect to z, we get, in the left hand side, we get the given integral because f of z value is e to the power of 2z. That is, integration of e to the power of 2z divided by z minus 1 into z minus 2 with respect to z, which is equal to, right hand side is integration of f of z divided by z minus 2 with respect to z over c minus integration of f of z divided by z minus 1 with respect to z over c. Now by using Cauchy's integral formula, we have 2 pi I into f of I is equal to integration of f of z divided by z minus I with respect to z over c. Give it as equation number 3. Left hand side is given integral, which is equal to, the value of this first integral is 2 pi I into, here a value is 2, therefore it is f of 2, minus the value of second integral is 2 pi I into, here a value is 1, therefore it is f of 1, which is equal to 2 pi I into f of 2 value is e to the power of 2 into 2, that is e to the power of 4, minus 2 pi I into f of 1 value is e to the power of 2 into 1, that is e to the power of 2. On taking 2 pi I into e square as common terms, we get 2 pi I into e square inside the bracket e square minus 1. This is the value of given integral.